Hello and good morning, everyone, and a very warm welcome to today's webinar for World Environment Day. Today's discussion is about a practical revolution and retrofitting New York City buildings to clean the air and slow the rate of climate change. My name is Katrina Brady of the World Green Building Council, and I'm delighted to be moderating this event today that's co-hosted by the World Green Building Council and the UN Environment. So thank you so much for joining us. So we're delighted to be kicking off the celebrations of World Environment Day here in New York. And the theme for this year's World Environment Day is air pollution, that has been selected by the World Environment Day host country of China. Now, the World Environment Day is the United Nations Day for encouraging worldwide awareness and action to protect our environment. Since World Environment Day began in 1974, this event has been the People's Day for doing something that takes care of the Earth. So today and throughout this week, there are hundreds of events around the world that are engaging citizens in the solutions to air pollution. And that's ranging from waste management in China to bike rides in Brazil and sustainable fashion in Kenya. And we're so pleased to welcome you all from around the world to today's webinar to focus on a local problem that has very global implications. So the topic of today's webinar is how New York City buildings are improving air quality and slowing the rate of climate change. I'm delighted to be joined today by a series of expert speakers, each of whom is going to give a brief presentation and participate in the question-based discussion. So please do pose any questions you have throughout this session in the question box. To begin the introductions, my name is Katrina Brady, and I'm head of Better Places for People at the World Green Building Council. I'm delighted to be moderating today's panel, and I'll begin by introducing my fellow speakers. Firstly, Nora Sturer is an associate expert at UN Environment's Energy and Climate Branch. She works with the city's unit with the Global Alliance for Buildings and Construction and focuses on questions of climate change, energy and resource efficiency as applied to buildings and construction. Nora is particularly interested in policy frameworks and economic and behavioural incentives conducive to energy and resource efficient cities and buildings, and she'll be sharing a little bit of her insight about New York shortly. Rafer Wallace is an architect and is the founder of Giga, an independent third party combining the development of building standards with cloud technology that increases the accessibility and impact of healthy buildings around the world. Rafer has pioneered standards for data quality, which are now used internationally, and they serve as foundations for both Reset and Origin, Giga's two primary areas of focus. Next, we have Marwa Zaatari, who is the Vice President of Building Solutions at enVerid Systems since 2015. She leads design of ventilation and filtration systems in buildings, manages systems installations and integration into HVAC systems, energy and indoor air quality protocol development, and field measurements and monitoring. Marwa holds a PhD degree in environmental engineering from the University of Texas in Austin and is a member of several ASHRAE committees and chair of the LEED Indoor Air Quality Working Group. Finally, Dr. Christine Bruckner is an architect actively supporting best practice, sustainability, and wellness in design. A director with Mmoser Associates, she brings her experience with urban integration, revitalization, and design excellence to guide development of our built environment at all scales. As a lead AP and BEAM professional, Christine is also an early adopter of the International Well Building Standard and leads Mmoser's global well integrative design solution initiatives. So thank you in advance to our four panelists for providing their time and expertise to this event. Now, before we hear from our panelists and to complete the introductions, I'm pleased to present a snapshot of the work that I do at the World Green Building Council to set the scene on a global scale for our discussions today. The World Green Building Council is a global membership organisation. with around 70 national green building councils around the world. This Green Building Council network represents around 40,000 members worldwide and works in the areas of awareness raising, training and events, certification and advocacy, and many more to implement a large-scale transition towards a sustainable built environment. My role is to lead our Better Places for People global project, which is active in over 30 countries of the world and is working to accelerate a sustainable built environment that is beneficial to both people and planet, with a particular focus on human health. And this year, as part of the Better Places for People project, we've launched a global air quality in the built environment campaign to bring attention to the role of the built environment in generating air pollution that's harming human health and accelerating climate change. We've been delighted to work closely with the Climate and Clean Air Coalition on this campaign, who are a global partnership organisation committed to reducing the impact of short-lived climate pollutants on human health and the environment. Now, we recognise that there are many sources of air pollution, but we want to amplify and take action on the increasing impact from our cities in polluting the air, both inside and outside of buildings. For today's webinar, we're going to be focusing on outdoor or ambient air pollution. Now, this ambient or outdoor air pollution I'm talking about is caused by a range of factors, including transport, agriculture, waste, and many more. However, the contribution of the built environment in both the construction and the operational phases cannot be underestimated. In the construction phase, the production and construction of building materials increases pollution across a global supply chain, but also in a very localized setting on building sites. As an example, the production of bricks is a huge source of short-lived climate pollutant emissions, with approximately 20% of the global emissions of black carbon being sourced to brick kilns, the vast majority of which are located in Asia. Then in terms of energy being used in buildings, we know that 39% of global energy-related carbon emissions are attributed to buildings, which is divided up as a 28% contribution from buildings in their operational phase and 11% from construction. And we know the vast majority of energy in buildings worldwide is sourced from fossil fuels, over 80% in 2015. So the energy demand is resulting in very, very high levels of emissions. Furthermore, there are even more pollutants being released from how we heat, light, or cool our buildings. And some examples are the burning of traditional solid fuels for heat or light is a major source of black carbon. And on the cooling side, many of the cheaper and less efficient air conditioning systems on the market are still releasing toxic chemicals such as hydrofluorocarbons into the atmosphere. And both of these gases are examples of short-lived climate pollutants which are potent to our environment and are contributing to our changing climate. Now, these are just some sources of air pollution, but the sources are causing the following effects. Firstly, increasing emissions from building energy use and construction. And the International Energy Agency have flagged that emissions from buildings are not on track to reach a reduction in emissions target, and that emissions from the sector are actually creeping to an all-time high, likely due to extremes of weather and global population growth. Secondly, this pollution has a human impact. The World Health Organization reports that 9 out of 10 of us do not breathe safe air. And as a result, this air pollution was responsible for 7 million premature deaths in 2016. And to add to this challenge, this quote from the President and CEO of the World Resources Institute, Dr. Andrew Steer, reminds us that curbing emissions and pollution from buildings is a test that is really ever increasing. As a building lifespan is typically 50 to 100 years, what we're risking is locking in emissions for the next century with poor building design and construction today. This is obviously a particular risk in parts of the world that are experiencing massive population growth. Now, this challenge is something that we as the World Green Building Council are looking to grow awareness of through the World Green Building Council's World Green Building Week campaign, titled Building Life, which we're launching today on World Environment Day. So taking place from the 23rd to the 29th of September this year, World Green Building Week is our annual campaign that seeks to raise awareness of green buildings as one of the effective ways to tackle sustainability issues. The campaign aims to raise greater awareness of emissions from all stages of a building's life cycle, and therefore encouraging new practices towards reducing emissions from buildings and therefore improving our air quality. The Building Life campaign is focusing on 6 areas of a building's life cycle: production, design, build, use, deconstruct and reuse. And throughout the campaign, we're going to be working closely with product manufacturers to seek out ways to source, produce and transport materials more sustainably. So if you're interested in learning more, please do head to the World Green Building Council website to get more information and see how you can get involved in our Building Life campaign. So it gives me great pleasure now to hand over to Nora Sturer of UN Environment. Nora's going to give us now some background on the New York City political context around air pollution and emissions.
Thank you so much, Katrina, and hello everyone. Good morning, good evening, depending on where you are. It is a great pleasure for me to be here with you today. And as Katrina has mentioned, I would like to give you a little bit of a policy context for a recent push by the City of New York to decarbonize the buildings and construction sector. This provides a context for some of the case studies we'll be hearing later. I did have the pleasure of being in New York City recently and had the pleasure of speaking with some of the city officials. It's really worthwhile noting what is happening there at the moment. Before I jump into details, allow me to give you a little bit of apologies for the there you go. A little bit of a background for the Global Alliance for Buildings and Construction, which is whom I work with. And this is because it also provides a global context to the importance of the sector for air pollution, for health, and for climate change mitigation. The Global ABC, as we call it, was founded at COP21 and has 2 objectives: raising ambitions to meet the Paris climate goals and mobilizing all actors along the value chain. In a nutshell, we work towards a zero emission, efficient and resilient buildings and construction sector through forging global and regional pathways to decarbonization, working with nationally determined contributions with countries, facilitating knowledge and best practice exchange, targeting policymakers, especially through our regional roundtables, and through keeping the sector under review with our global status report. The next one is launched at COP25, so do stay tuned, and through shaping the global agenda. We have 120 members, among which are 27 countries. If you're interested in joining, please do feel free to reach out. As Katrina has already mentioned, the buildings and construction sector impacts are huge, and we see a 36% of global final energy demand and around 39% of global energy and process-related emissions. It is estimated that it is not possible to achieve the climate agreement goals without decarbonizing this sector. And in that context, it is particularly heartening to see cities like New York taking actions of doing that. And without further ado, allow me therefore to go into the details a little bit more of the New York City Climate Mobilization Act. And this is really a comprehensive and holistic approach for the entire city, for which buildings and construction play a particularly important role. And what is noteworthy here is also the strong links to livability, to well-being, and to health. And you can see here the highlighted parts, the framed parts that link to buildings. So modern infrastructure, thriving neighborhoods, inclusive economy, healthy lives, livable climate. So it's really this strong link to how that people can live their lives well and healthy. A couple of words about the emissions profile of the city. So New York City currently is at 51.7 million tons of CO2, and the majority of which can be attributed to the buildings and construction sector, which is why it's such a particularly important sector. So we see 30% for transportation, and if we then look into buildings, fossil fuels account for around 40% and building electricity for 25%. The New York City essentially has set two goals that I would like to talk to you a little bit more about. We call it here 40 times 30 and 80 times 50, or 40 by 30 and 80 by 50. What is meant by that is 40% reduction by 2030 and 80% reduction by 2050. For the latter one, 80 by 50, they've actually pushed further than that now and are aiming for citywide carbon neutrality by 2050. New York City is estimating with this goal that 6 million tons of CO2 equivalent will be reduced, around 27,000 jobs created, 150 hospitalizations avoided, and around 100 deaths prevented per year. So also here, strong connections to health. A little bit more about the measures for decarbonizing the buildings and construction sectors. I'd like to divide them into 5 pillars, but this is our assessment. This is not necessarily, this kind of division is not necessarily from the city itself. It's just to increase understandability. Firstly, there are measures around green and solar PV roofs. So new construction and substantial renovations are required to install solar PV, green roofs, or both. Then there is also an energy efficiency grade similar to the hygiene grade. For those of you who know the US and who've been to New York City, in restaurants, you see the grades between A to D, depending on how hygienic it is there. So the idea would be to do something similar for buildings. And this is what it would look like. You can see on the left side the buildings qualifying for A, and on the right side those who would be D, and that is based on the Energy Star labeling. Another 2 pillars relate to energy efficiency loans, and New York City has included PACE financing for energy efficiency and renewable energy projects with long-term and little or no money down. This type of financing rests with the property, so the loan does not rest with the person, the individual, which decreases risk for the individual. And then there is a pillar that I like to call 50,000 for 50, and that targets the high emitting buildings, so the really large buildings that are larger than 25,000 square feet in size, and they must meet emission thresholds starting in 2024. So why targeting those buildings? I think this is a very interesting measure that New York City has taken. Those buildings only represent about 5% of properties in the city, but if you look at their energy consumption, they represent 50%. So in a way, you could say it is a hotspot approach. This is just to give you an overview to compare the 2050 target with the current emissions intensity in 2016. And what you can see here that currently only the very best percentile on the far right side would meet that target, which highlights the importance of setting such targets and the ambitions and the strong measures that are required. Finally, there is a pillar that the New York City has implemented, local law 97, which includes prescriptive measures for buildings, and it also includes some measures especially for affordable housing. And I think there's also a very strong link to the health aspects. So some of the measures on the left side in dark blue include prescriptive conservation measures for rent regulated housing. That's a little bit also addressing the split climate incentive, a carbon trading scheme, city operations emission reductions of 40% by 2025 and 50% by 2030, and NYCHA properties, that's the New York City Housing Authority properties, need to meet emission reduction of 40% by 2030. There's also a whole range of measures around a greenhouse gas emission budget approach, where architects and engineers calculate this budget and report emissions accordingly, and those buildings who exceed their budget are then fined. For affordable housing has more time to comply with this measure to ensure that any measures taken do not decrease affordability. At the same time, also there are measures in place because it is recognized that energy efficiency is especially important for those with lower means. And those measures include things such as repairing heating system leaks, insulation, and installing and upgrading ventilation and lighting systems, as well as weatherization. One or two sentences on the overall approach. I think two things are very noteworthy. The first is really the connection to health and livability, and the second is that the city started with a target of carbon, of emissions, of decarbonizations, not with, for instance, energy. So essentially they started with a final result that is supposed to be achieved, and I think this is very noteworthy because it ensures that any policy, any measures taken are really results oriented. That's all from my side. Thank you so much for listening, and back to Katrina.
Thank you so much, Nora. I'm sure we'll all agree that was incredibly insightful and sets the scene fantastically for our two forthcoming case studies of New York City offices. In particular, from my side, that graph you've just showed us, Nora, that shows that almost no buildings are operating within the 2050 limits today, really makes the scale of this challenge clear. So thank you for those great visuals. Now, I'm delighted to hand over to Rafer Wallace of Giga, who's going to give us a bit more information on the public health emergency that is air pollution. A quick reminder to all of you listening that the question box should be open for you all. So please feel free to pose any questions throughout the forthcoming sessions, and we'll come to as many as we can in the later discussion. Thanks very much, and over to you, Rafer.
Thank you, Katrina. A quick note before I start, I am calling in from the host country, calling in from China, and there are some slight delays in the timing of the slides, so if the words don't quite match what you're seeing, I do apologize, and I'm not completely insane. The delays at work. And as I say that, aiming to switch as we speak. But in the meantime, a very brief word on who we are and what we do. RESET is an international building standard focused on assessing the health performance of real estate around the world in real time, all based on sensor data. There we go. And so here, just showing a slide of how we look at building optimization. This is measured on a half-hour basis. And in order to do this, there's an infrastructure in place, which skipped, but I won't go back. That looks at hardware quality. So we assess air quality monitors from around the world for data quality, as well as software quality, and then finally look at the overall project performance. On point for today in terms of air quality, I think everyone's fairly familiar with healthy buildings being, and the topic of health being very large issue globally, and we often get asked what is the first and most important aspect to tackle, and it's always a bit of an easy answer, air being number one, given that we breathe 15,000 liters of it on average per day, and tends to add a little significance to why the few metrics that I'm going to go into in a moment are so so significant. Some of the stats here, just as a quick summary for the listeners, hopefully all familiar with, but 90% of global population exposed to some of the pollutants we're talking about today, resulting in just under 9 million early deaths each year. There's a new report that really just summation of a number of reports that came out several weeks ago, looking at how outdoor pollutants affects pretty much every organ within the body. And this is fairly commonsensical when we take a step back, especially when it comes to particulate matter, where, for those who are familiar with PM 2.5, these are harmful particles that enter directly into the bloodstream and then get distributed to every organ within the body. And so without going into huge depth here, just pointing out the main ones, lungs and heart being the obvious ones, leading to asthma, lung cancer, and heart disease. Beyond that, brain and mind, leading to stroke, dementia, reduced intelligence, eye problems, skin aging, and healthy list goes on, pun intended. Looking at abdominal organs, they're kidney cancer, bladder cancer, diabetes, Crohn's disease, fatty liver disease. And finally, although the response here is a little bit slow, just keep moving that forward. Finally, looking at reproduction and the effect on babies and children, which is probably the most significant, given children are still at the development stage, and giving their air to body mass ratio are by far most affected. But reduced fertility, miscarriages, and low birth weight are very, very common in places like China and India. And then also looking here at effects on other geographies, and highlighting the fact that these minor changes in air quality, again, because we're breathing so much air per day, minor lifts like a small change of 35 micrograms per cubic meter, which are fairly common occurrence in cities like New York, have, again, significant impact. So 10% increase in risk of lung cancer and 35% increase in risk of stroke. These are very, very significant figures for cities such as New York. Then just wrapping up and setting the stage for our two case studies. On the reset side, the participating projects track outdoor air quality being delivered by mechanical systems into tenant spaces, and then finally the air being breathed by tenants. And this gives us a wealth of insights on what's actually happening within buildings as compared to outside, and the various challenges that are at play here, which is what our two case studies will be diving in. And this particular graph here is a little bit heady, but work with me. Very significant. The brown line that you're seeing here is outdoor pollution, in this particular case, particulate matter. The purple line that you see going up and down is the building being turned on and off. And the gray line at the bottom is the indoor pollution. And so what we're seeing here is a very typical process of a building mechanical system being turned on. And if it's running properly, is effective at filtering out outdoor pollutants and keeping indoor pollution within range. But obviously at a high energy cost, which only makes the outdoor problem worse. Then the following slide is just a quick snapshot or focus on the area for what happens in the evening, where a building mechanical system turns off and the building deflates like a balloon. and in the process pulls all pollutants, or not all, but a large percent of pollutants that are outside in. And so what we see here is that within an hour, the outdoor pollutants, the indoor pollutants match outdoor pollutants. They've all been pulled into the building. So anybody overtiming in this particular case would be directly exposed to those pollutants. And so here, just highlighting the how quickly air dynamics can change within a building, pulling outdoor pollutants in, exposing us in areas where we think we're protected, and the resultant battle on how we look to control these while reducing energy cost to, again, reduce the source impact. And on that, just in terms of setting the stage, I'll pass it over to Marwa at enVerid.
Thank you, Rafer, for sharing that with us, and thank you for managing to connect with us direct from the activities in China for World Environment Day. So yep, as Rafer said, let's hand over now to the first of our New York City case studies, a financial services client of enVerid Systems, presented by Marwa Zatari.
Thank you so much, Katrina. I'm very excited to be here. So far, we talked about outdoor air pollution and ways to reduce it. But what about indoor air quality? The fact is that most of us spend about 90% of our time indoors. That's a staggering 22 hours per day. And the majority of our exposure to outside air pollution actually happens inside our buildings. So I will be focusing my talk on the 90%. The traditional approach to maintain indoor air quality in buildings is to bring outside air to dilute indoor pollutants, such as carbon dioxide from people or formaldehyde from building furniture. However, when you bring outside air, you need to condition it, meaning that you need to spend more cooling and heating energy. In its turn, spending energy will lead to higher outdoor emissions, and you will be contaminating your building even further with outdoor pollution. This is a vicious cycle, and clearly it means that buildings should not depend on outside air as a solution to acceptable indoor air quality. Instead, buildings must adopt strategies to maintain indoor air quality and not spend more energy. Even better if they can find strategies that can maintain indoor air quality while lowering energy consumption. The solution I'm presenting here does exactly that. HVAC load reduction, or HLR, is an intelligent modular scrubber that includes sorbent materials. So during normal operation of the building, the HLR will clean a fraction of the return air from gaseous pollutants, and then it puts it back into the return air stream. And in addition, this module is equipped with sensing capabilities to actively monitor return air quality. So as a result of cleaning return air, the building can dramatically reduce outside air requirements, therefore saving energy and keeping the pollutants generated outdoors on the outside and keeping indoor air quality below acceptable levels. So the building you see in the middle of the picture is an example of a building located on Times Square in New York that was retrofitted to include the HLR modules. The building is a financial institution, a Class A office building. It occupies 1.3 million square feet, 44 floors, and maximum occupancy of 7,000 people. The building is open 24/7, and the first 4 floors of the building are trading floors. The building achieved LEED Gold certification in 2013 and Energy Star certified. The heating, ventilation, air conditioning in the building uses 16 different air handling units divided equally between the 7th floor and the 28th floor. To identify these floors, you can look at the black outside air intake louvers. So all the air is conditioned on these 2 floors and then being distributed to the rest of the buildings. So the client approached us with 2 main goals. The first goal is energy efficiency, of reducing energy emissions by 15%. The second goal, equally important, is to reduce the flow of outside air pollutions indoors and actively monitor and manage the air quality inside the building. So the retrofit consisted of installing 40 HLR modules in the building mechanical rooms. A slipstream, or a bypass, of return air from the plenum is drawn through the HLR modules to be cleaned before it gets distributed to the rest of the floors. The pictures I put here on the slide shows an example of the installation on the 7th floor. You see a cluster of 10 HLRs module, 10 on the north and 10 on the south side. And the 28th floor has an equal number of 20 HLRs, so total of 40 HLR modules. These modules are connected to the building management system, and after installation, we determine the new minimum outdoor air position that we can operate the building at. And also after installation, we performed outside air quality and indoor air quality measurements, and then energy measurements to compare the building's result before and after this retrofit. I will start with the indoor air quality results. We have here a chart showing ozone concentrations measured during August of 2018. The left axis is ozone in parts per billion, and the x-axis represents the date. The red line shows outdoor ozone concentration measured on Times Square. These concentrations were very high and reached a high value of 90 parts per billion. This is 1.0 times higher than the outdoor limit. The blue line shows indoor ozone concentration before we did the retrofit, meaning that the building was still bringing a lot of outside air. And you can see that the blue line, indoor concentration before the retrofit, tracked very closely the outdoor concentration shown in red. Around 50% of outdoor ozone was brought inside. Think about this. This is actually pollution you introduce from the outside to the inside. Now the green line shows indoor ozone concentration after the retrofit, after we closed the outside damper to a minimum and we operated the HLRs. And you can see that the indoor ozone values were less than 10 parts per billion, and this is a major improvement over the baseline, considering that for ozone, this is one of the pollutants, similar to particulate matter that Rafer mentioned, has no indoor limit. The lower, the better. So moving to the energy results. So by making this retrofit and installing the HLR modules, we reduced outside air 85%. As a result, the building saved 500 megawatt hour of cooling and dehumidification of the outside air, and 4,700 million BTUs for heating the outside air. This led to $413,000 saving in utility bills, including $10,000 in water energy bill, basically. Also, the building obtained very healthy rebates from Con Edison. And by reducing the conditioning of outside air, the building saved a remarkable 1,361 metric tons of carbon dioxide. This is my last slide. I put a headline from New York Times, published in April 2019. I know Nora talked in detail about the Climate Mobilization Act. I want to put it again and say that New York City became the first city in the world to constrain large building emissions through hard limits. People are saying that this bill is similar to the New Green Deal for New York, and it will be the largest disruption in the history of New York City real estate. So buildings need to do deep energy retrofits, and if the owner is not in compliance, they need to pay fine, and it will be ongoing fine based on their actual emission versus the cap. So to put things into perspective, the Bank of America Tower, located on Bryant Park, was actually the first building to achieve Platinum LEED certification in New York, will need to pay $2.5 million in fines in 2024 if they don't reduce their emissions. With that, thank you so much.
Thank you so much, Mara. That was a fantastic presentation, and I'm sure everyone listening will agree that you've illustrated that link between indoor and outdoor air quality in buildings so well. And personally, I find that cost-saving element really interesting. So I am sure our audience will have many questions for you. I can see the question box starting to pop up. So a reminder to anyone else to write any questions you have for Marwa or any of our other speakers in the box, and we'll come to them in the discussion shortly. But last but not least, I am delighted to hand over to Dr. Christine Buckley of Mmoser Associates to tell us the story of their internal retrofit to lower emissions and improve air quality.
Hello, thank you, Katrina. This is Christine Bruckner, and I am delighted as an architect and director with Mmoser Associates to share with you our New York office, which is located in the Woolworth building. The historic landmark of the Woolworth Tower, and you can see some of the original imagery here, In 1913, it was the tallest building in the world, and it held that place for almost 2 decades. This is something very special, and we were very drawn to this building in a way to find an office that could use an existing building, capture its character, and yet create an indoor space that meets all of the highest standards available: LEED, WELL, Reset, and beyond. So this landmark building, and you can see the photograph we've taken on the right, showing the exterior, the terracotta, and some of the windows. Woolworth himself worked with the architect, Cass Gilbert, to say he really wanted to maximize windows so that all of the offices would be well lighted. This was achieved, and in fact, in this old building, what you find is that the spaces can all get their natural daylight. Are we moving forward here, the slides? There we go. And you can actually see in this pictures here, we're revitalizing this historic Woolworth Tower. We were able to take advantage of that opportunity to have light by using daylight controls and reducing energy use through maximizing the natural light that comes into the space. And there are many ways that we did this, but sensors is one way that we reduced energy load. And we're going to be talking more about this at the end of this talk, but by reducing our energy load in multiple ways through our design integration, we can make a big difference, which not only saves money, but also really can help the air and the carbon outside in New York City. So beyond revitalizing, there has been a lot of redevelopment work on the Woolworth building. And we won't go into all of the details because it's been going on for over 100 years. But as a landmark building, New York City has mandated several things which have taken care to preserve the character of this building. And those are combined with the policies that Nora shared. These are really working to preserve the city of New York. And it insisted that no matter what upgrades were done for health and safety, they be done in a way that was hidden and would not impact the look. We've talked a bit about this already with Rafer and with Marwa, but how does the office environment affect air quality? There are multiple ways. The particulates from photocopiers, the volatile compounds and the formaldehyde, the dust, the mites, the mold. There are many things that are out there that a building gets to work with. So what we've done is we've actually monitored this. And similar to the example that Mara was sharing, we have set this up so that we know minute by minute what is happening with the air quality. And that's on the inside. This is important so that you can see how you're standing and make sure that you are presenting a healthy environment. By simply adding more filters and making sure that we use healthy materials, healthy cleaning programs and processes, we were able to ensure that PM 2.5, TVOCs, which is the total volatile organic compounds, those rates all stayed well below what you can see as a blue line, which relates to Reset and WELL standards. Far below them is where we want to be for health. Again, for CO2, we really want to make sure that people have enough fresh oxygen and air. This is important inside, and also by reducing the energy use, we can help to make sure that the air outside will also be clearer. Here's an image of the revitalized space. It's a very fluid space. You can see the windows are quite open. We have the sensors for the air conditioning that's being monitored, sensors for the lighting systems, and you can see the green walls, which we'll talk about later, and the healthy materials. There are certain other softwares and analytics that were utilized by the building itself to help to further ensure reduction in energy. So we have to be working at the building scale and at the tenant scale. If we go to the tenant scale, one thing that you can do that's quite straightforward is the incorporation of green walls. And these green walls are actually called the Nava walls, and they work as an air purifier. They are actually helping to create a healthier environment. They're taking care of your air. They're pulling air right through the roots of the plants, improving the space that you're in, but they're doing many other things simultaneously. They're creating a very healthy environment. They're creating an inspiring biophilia, and they're working together with the design. You can see here that we actually have designed this space to be very fluid, again, to take advantage of the natural daylight, the high ceilings, and these walls can move around. We refigure them, reconfigure them frequently. All of these pieces can move so that we can clean very regularly, again, with natural and green materials, so that the air quality is staying healthy. But how does this affect New York City's exterior air quality? And I'll go back to that simple point. By being energy efficient, we can all make a difference to the exterior air quality. And certainly those projects that are working towards LEED, that are following other best practices, will see that you've reduced your energy loads. This is a few examples of what's happening in the New York Mmoser office. And the reduction numbers are printed there. You can see every detail, every specification has to be considered. And this is, again, not just about saving money. This is about truly creating a responsible environment, a healthy place to work in, reducing operational costs, reducing energy costs, but improving employees' well-being, mental well-being, and ultimately including the surrounding outdoor air quality. And it's important, you can see in this quote that the Woolworth building itself is a prime example of how we can use existing buildings, creating and taking an old building and showing that you can create state-of-the-art platinum well spaces within them. And in fact, Mmoser selected this heritage skyscraper just to truly show this and to show how important that character is and how important it is that we look at all existing buildings and improve them dramatically through the way that we specify the interiors, the way that we work together to reduce embodied energy and save the legacy of New York. You can see again the space, it's been reconfigured since the last photo, and let's work together towards a sustainable future, and we look forward to discussing more details with more time.
Thank you, Christine. I think everyone will agree that you give such a unique and interesting perspective to hear, for a change, from the occupier of a building, as well as the designer bringing in these amazing health and well-being and environmentally positive design principles. And we'll look forward to hearing more from you shortly. So in the last 10 minutes of this webinar, I'm delighted to be able to open the discussion up to all of our panelists from today, and to ask some of the questions that have been posed from our audience around the world. So thank you so much to those of you who have written in the box. I've got a nice long list of them here. So let's kick off the discussion with something that's popped up a bit in the question box, and a dilemma that's actually been discussed a fair amount in these presentations. This tension point, this dilemma between building energy use and emissions versus maintaining a good and healthy indoor air quality. And I think let's come back to Christine and Marwa first, because you've given us your own experiences and insights, so thank you so much. But what advice can you give to those listening on both the tenant level and the building owner level in terms of solutions to achieving good indoor air quality without raising emissions? Christine, let's come to you first.
That's a perfect segue. So again, the first recommendation is absolutely to implement a design solution which enhances the given natural light within a space. And designing through transparencies and openness so that you can incorporate even things like light shelves and diffuse reflective surfaces so that you're bringing that natural light as far as you can into the space. This, coupled with the occupant, the daylighting sensors, will significantly reduce energy, which in turn will reduce your emissions. Another aspect would be the materials. Not only specifying healthy materials that will not off-gas, but specifying local materials and making sure that there's minimizing the transportation, even taking care of how they're delivered, no idling, delivering off-peak. There are many subtle differences that we can make to improve. And again, one thing that we could look for would be longer leases, because if you don't need to change your fit out as often, then you're going to save quite a bit. And also you can design to incorporate versatility. That one slide I showed where we can move the walls around, where you can change the number of desks. If you need to make changes as a tenant or even as a building owner, those changes can often come at a great cost with a lot of waste. A lot of things will be thrown away, and there is no away. So creating a versatile environment which can change easily and seamlessly is very important. And I guess ultimately, there's small things that we can all do, like really unplugging, getting rid of even the vampire use of energy where you leave things plugged in but sort of off, truly turning things off over the weekends, in the evenings, even when not used, and creating a culture about that. We found that actually creating IT server rooms that are incorporated, not even enclosed, can reduce quite a bit of energy use, because you don't need to have those air conditioners in those rooms 24/7. So there are multiple ways that you can do it, and a simple one, of course, would be stairs. So I could go on forever. Let me let Marwa answer a few.
Thank you, Christine. I second everything that Christine said. So the key is that buildings must adopt strategies to balance indoor air quality and energy consumption. So I shared in my case study one way to basically do air cleaning, reduce outside air requirement, where everybody wins. The building owner will win by reducing costs, the tenant by improving the indoor air environment, utilities such as Con Edison will win by decreasing the peak load on their demand, and the environment will win by decreasing emissions. Now we see a lot of pushback from owners because of the initial investment to make this retrofit. But consider this. It might cost $3 per square foot for utilities, $30 for rent, and $300 for salary for employees. So if you can design buildings from the beginning or retrofit them in a way to affect the performance positively of occupants, that could make a big change in the company's bottom line. And new studies from Harvard show an increase of $6,500 per employee per year if the air quality is improved. And similar finding from research from Lawrence Berkeley Lab, where they say $20 billion is the estimated economic benefit from improving indoor air. So there's definitely a case to be made to improve indoor air quality, and definitely a lot of solutions, like Christine mentioned, to improve indoor air quality, but not at the expense of energy.
Thank you both. That was a great answer. And Mara, you've touched just there on the payback, and thank you for giving us some academic references as well. But we've had some questions about what the payback period is for installing the HLR system that you presented about. So there's a question about the payback period for installation, and secondly, is it difficult to install in terms of training the workforce?
So let me answer the payback. Unfortunately, every time we talk about payback, we only talk about energy. So we say, okay, what are the dollars and cents in utilities, utility bills to make this installation? We ignore what I said about the benefits for the company to improve air quality, which can be, if you talk about the benefits of worker performance, can be way bigger than talking about saving on energy. Nonetheless, there are amazing programs by Con Edison in New York to offset the cost of the retrofit. They give actually up to 70% of the cost of the retrofit. They give 30 cents per kilowatt hour saved and $1,620 per kilowatt saved. So if you put this into perspective, together with how much employee performance will be improved, the payback is very short. And now, of course, it depends on the specific buildings, specific occupant density, how long does the building operate. What was the second question, Katrina?
The second question was, is it difficult to install in terms of training the workforce?
It's definitely a steep learning curve because it's basically it's a new way to run the buildings. But with basically awareness of what the equipment does and basically initial training and the capability to monitor the units on the building management system and the alerts and the ongoing air quality display, we found that the building manager and the employees will get the hang of it.
Thank you so much. Okay, so let's come back to our focus city of New York for the next little round of discussions. And I want to come back to some of the policy successes and lessons learned that Nora talked about in her opening presentation. And Nora, we'll come to you first on this, but you talked a lot about policy, and I wonder whether you would suggest that there are any lessons learned or any successful policies from New York that could be rolled out in other cities around the world to achieve these positive health outcomes you talked about.
Yeah, thank you so much, Katrina, for this question. Absolutely, I think there's a couple of lessons learned for other cities on the links to health. I think first and foremost, it's really this overall, this comprehensive approach the city has taken, the Climate Mobilization Act, and in that already they made it very clear that it is, yes, it is absolutely about climate, but this cannot be separated from well-being and from health. They made that clear for buildings, and they made that clear. I mean, if you recall the very first, I think the first or second slide I had, them made that clear just in the wording they chose on, inclusive economy, thriving neighborhoods. I think this sort of framing is incredibly important and also really helps with buy-in in other cities. And there's an aspect of communication as well. I think the second thing is to really look at the emissions profile of a city. In New York, we see that really a large share of emissions from buildings come from fossil fuel use in buildings. So to highlight that, and to highlight the reduction exactly of that and the health benefits that has. I think that's a really important aspect as well. And finally, I think another really important aspect on health and on air quality is also the question of cooling and of refrigerants, and to approach this in a holistic way that New York City, I think, has done, namely from a performance perspective, from a whole building's perspective. So not necessarily just looking at equipment and saying, yes, you would like more efficient ACs, for instance, but really to say, okay, we need to decarbonize the entire building. We need to think about the entire building design, and through that reduce the very need for cooling, reduce the very need for refrigerants, reduce the need for energy, and thereby reduce the use of fossil fuels. And I think all of these are fantastic lessons to take up. Final 2 points. The element on solar panels or green roofs is a great connection to health as well. And the inclusion, the specific mention of affordable housing and of increasing well-being and health for people living in affordable housing is a great aspect and a really important aspect as well.
Thanks, Nora, and great to have you circling back to cooling as well, because it's such an important issue that we could quite easily talk for another hour on, I'm sure. But a question that's come in that I'm just going to pose to you because you're right here now, but we've had a question asking, what are the main sources of ambient pollution that are entering buildings in New York? Is it mainly from buildings or is it from road traffic?
That's a great question. And to be honest, there, I would really like to go back and look a little bit deeper into research, because I would not want to, I think this is quite specific. I think it probably depends on what kind of error, what kind of source pollutants you're talking about. If you're talking about fossil fuels, in New York City, at least, buildings are incredibly important. If you recall the first slide, or one of the first slides, it's 40% of emissions from fossil fuels for buildings. It's 30% of emissions for transport. So there, probably actually buildings is really important, but you have other source pollutants, and their transport is incredibly important. So, you know, if you take a citywide perspective, both sectors, I mean, you cannot leave out one sector or the other. I do think New York is specific in the sense that the emissions profile just really points to buildings. If you'd like a breakdown, let's say, of the source pollutants, I'd need to come back to you, or maybe connect you to city officials. But yeah, I think for fossil fuels, really need to look at buildings.
Thanks, Nora, and sorry to ask you such a difficult question, but a really helpful response. And we're just coming up to the end of the hour, so I'm going to pose one last question to all four of our panelists. And let's see if I can ask you for a brief response, a one-sentence response from each of you. We'll come to Christine first, then Mara, then Rafer, then Nora. But the question I'm going to ask is, in terms of assigning responsibility for cleaning up our air, who do you think should be responsible? And what do you think the role is of policy versus the occupier in changing behaviours and practices that amounts to air pollution? Christine, let's come to you first for your closing words.
Thank you, Katrina. Everybody is responsible for our own air quality. Everything that we purchase, every material that we specify as architects, that we use as users, that a building chooses to focus on, every single material and choice of transportation is important. I would say the cleaning equipment, the integration of stairs, the culture of caring and understanding that we're all responsible and we can only do it together is one of the most important aspects that we can share. And as an architect and designer, I think it is through design, through raising awareness for the importance that designing effectively with effective materials and effective measures that are versatile and long-lasting, just like our buildings can be. I think that's the understanding that really needs to be shared. And it's shared by the building owners, it's shared by the tenants, it's shared by the users, it's shared by the citizens of the city.
Thank you, Christine. Mara?
I second what Christine said. Everyone is responsible. I do also feel that the role of policy is critical. Like Nora mentioned, the Climate Mobilization Act, I think it's a game changer because no one likes to pay for whatever they're always gotten away for free. So I think it's critical, the role of the policy to basically accelerate that change to better buildings and better environment.
Thank you. Rafer?
Yeah, thanks. We've seen across the hundreds of projects that we track that the most effective points are the building owners and the tenants from just a pure air quality perspective. And a lot of that is actually driven by a topic that we haven't really hit upon, but it's liability and just demand, tenant demand for clean air. So fully agree that everyone's responsible. Those are the key drivers that we've seen, and the main impetus behind that is the ability to measure. And of course, you can't fix what you don't measure. And so those would be those not would be, but are the two biggest influencers we've seen. And then of course to really pin down on carbon emissions and energy, then that's got to go to city level. So the kind of the three-partite responsibilities that are definitely the most apparent.
Thank you. And Nora, final remarks?
Thank you. That's a fantastic question. And I love the term of responsibility because I really think I agree with the previous speakers. It's a shared responsibility. I think a special role comes to policy because they set the framework for everyone else. I've had fantastic discussions with people in New York City, and someone mentioned, the market is really important. We need innovation from the market. The market will do it. no question that the market is doing fantastic things, and we've heard great innovative examples. But if the market would do it, they would have done it now. It's not happening on its own, certainly not according to the scale and the speed we need. So I think their policy is just critical, and we see cities at the forefront. I mean, New York now, we've discussed this here. New York built up on other cities that, because of innovative policies, are at the forefront, such as Vancouver and Brussels. They actively went to those cities and asked, what did you do? How did you do it? To learn from them. And I think that just goes to show that with the right framework, with the right policy framework, and with everyone in the boat, we can really make that change.
Thanks, Nora, and some great last remarks there. So thank you to the panel. And of course, a huge thank you all very much for joining today's session. It's been such a pleasure moderating this really interesting and very valuable and topical discussion. So thank you again to our speakers, to Nora, Rafer, Marwa and Christine for your input and your time in preparing this, and to Sandra and the team at UN Environment for facilitating this event. This recording will be available on the Climate and Clean Air Coalition website, and we'd of course invite you to share it with anyone who missed it. And wishing you all a very happy World Environment Day, and thank you again for joining us.